Alright, so to get an idea of what's going on, I'm going to try to graph this myself. It's not going to be a perfect graph because I don't have graph paper on the test, but it'll be a good sketch. So I have 1, 2, 3, 4 for the radius, and then maybe I have to go from 0 to 50, so maybe I'll go by 10. So I've got 10, 20, 30, 40, 50 for the area. So if the radius is 0, the area should be 0. So right on the corner there, don't be afraid to mark in the corner. When the radius is 1, the area should be 3.14. When the radius is 2, the area is 12.57. When the radius is 3, it's 28.31. When the radius is 4, it's 50.29. So there's my graph. I can see that the points are going up, so I think I can safely cross out that one. It doesn't look like it's going to go down again. And it also looks like I can cross off this one, because it certainly doesn't look like it's going to level off. So those two are out. And now I've got it between this one and this one. Now I've done a pretty okay job of plotting those points, so it kind of looks like B. But if your graph wasn't so perfect, or you just wanted to be sure, why it's not A. So our answer is in fact B. So it goes like that. It's an exponential graph. But why isn't it this one? Why isn't it linear? And it's not linear. We would be able to tell if this thing were linear, because linear functions, what makes them linear is that they increase by the same amount every time. So from here to here, if I increase by 3.14, from here to here, I would also have to increase by 3.14 to be linear. For every one jump here, I have to have the same jump there. The slope between any 2 points has got to be the same, and from here to here, that's certainly bigger than 3.14. So therefore, it is not linear. So not A, B is still our answer. We're still done with this problem, but I still like to talk about it. That 3.14, does that look familiar? That's pi, right? So it looks like we're actually, what are we doing? 3.14 times, yeah. So the area we know is supposed to be pi times the radius squared, and that's the formula for area. And you see that the r is squared, and that's why you're getting this quadratic look. So, and the pi is what that is, because when the radius is 1, it's 1 squared times pi is 3.14. So you could have actually generated those numbers by yourself. They didn't have to give you the table, because this is one of those formulas we should know. So what am I talking about? I'm talking about like linear. Things look like y equals mx plus b, where x is to the first power. Quadratic equations look like y equals. This is a little bit more involved than you need from this test, so if this is freaking you out, don't worry about it. But quadratic, the biggest power of x you see is to the second power, and the graphs that you get are parabolas. And of course, for linear, where the highest power you see is a 1, linear, the graph is a line. Yeah, I called this exponential before. That was wrong. Quadratic. I'll fix that in a note. Okay, that's all I have to say about that.